Assalamualaikum and welcome to my video. Today, my name is Anik Syairan Bishar Razwan. I am from 1BEL. Today, I want to present my project. The name of my project is Unbiased Electronic Dice. In this project, I will show a simple unbiased electronic dice with LEDs. This project consists of 6 LEDs, a 555 timer IC, and a 4017 decade counter IC. This is a 4017 decade counter IC, and this is 555 timer IC. um, why I'm do this project, because playing with a dice is an age-old game, as we know. We all love to play with it too. Playing with dice need us to pick up a dice and make sure that it's unbiased. Making a block as a dice and cutting it clearly to make sure that it is unbiased is all an old story that dice become biased if the shape is not cut well. Also, the dice can become biased due to deformation. If it is a wooden die, it can deform due to dampness in the atmosphere or due to mechanical stress. To solve all this problem which we have with a conventional dice, we have made a die circuit which solve all the problems of a conventional dice. Now we are going to show you an electronic LED dice which is nearly unbiased. There is no chance to cheat, as the circuit operators at such a high speed that circuit is almost imperceptible to the human eye. There is also little maintenance, and there is hardly any impact on again of the circuit. The frequency may vary a bit with a change in power supply voltage again of the active and passive component, but still the randomness will be preserved without any trouble. The component component required, I'm using 6 LEDs, as we know. 1 is 1, 2 is 2, 3, 4, 5, and that's we know 6. And I using 55 timer IC. This is 555 timer IC. I'm using CD 4017 decade counter IC. I'm using push button. I'm using resistor. I'm using 3 resistor, 2 capacitor. That is just a that's all. After that, why I'm using 55 timer as why I'm using this IC 55 timer, because it has an stable multi-vibrator. With this complication, the circuit operator as a pulse generator with a frequency in order of kilohertz. This means that circuit produce a clock cycle about 0.00021 second, which is imperceptible to the human eye. We cannot observe the values which change at the faster rate, so there is hardly any possible of getting the dice biased. The clock pulse are given to counter come decoder circuit IC 4017 with the 7 output given to reset. It has 9 possible outputs, out of which the 7 is given to reset, because we only need a count of 6. 1 2 3 4 5 6. So the 7 we reset. We go to 1. This 1. The first 6 output are given respectively to the LED, so the respective LED will glow for the corresponding count. if the count is 1, LED is 1 will glow. If the count if 2, LED 2 will glow, and so on until the 6 count. I want to simulate to show how the circuit function. We just push, and after release, the LED going to move to another LEDs. If this 1. Alright. In this count, the circuit reset itself as the 7 count is given to the reset pin, which is pin 50. This is pin 50. Let me tell you that the power supply pin and ground are not shown in the circuit diagram, as it is the schematic generated by the software Proteus. However, the power supply of 9 volt is given to the 6 pin of IC 4017, and the 8 pin of IC 4017 is given to the ground. This is how the circuit function, and you can increase the frequency of the circuit if you feel that you need a more randomness. So that is very hard to perceive. This circuit can be implemented on the general purpose PCB with 9 DC power supply. This is circuit, and this is PCB layout as I show. This is PCB push button, power supply, ground, resistor. I'm using capacitor. This is IC 555 timer, and this IC 4017 counter, and this is LED, and visual 3D visual like this, and the circuit behind of this PCB layout. 6 LEDs, 1 IC counter, 4017 555 timer. I'm using capacitor, resistor, push button, and power supply. That's all. Thank you. That's all. Assalamualaikum warahmatullahi wabarakatuh.